Yeah, this is a filter board. The low pass filtering for 7 megahertz, so for 40 meter band. So that is definitely a problem. So 740 meter low pass filtering is through this little relays at the beginning, and so that's the input relay, and that is the output relay, and that is transmit and receive switch relay. So at the moment it looks pretty nice. So marker is at 7.1 megahertz, and we see that it is falling down, so that is what you expect from a low pass filter. So low frequencies are passing through and high frequencies are attenuated. So that is what you're expecting, but minus 13, 14 is not good. So there should maximum minus. So I'm just injecting minus 10 dB. So for the moment in time, we have attenuation of about 4 or 5 dB, which is too much. And yeah, if I touch the board, then you can see it is only 1 dB attenuation. So that is what we really expect, and that is really the curve we are looking for. So everything else is what we don't want. So also I have already reflowed the PCB. There is still a problem. So that is what you can see here. So that is 40 meter filter, low pass filter. Still a problem. Yeah, so that means I have to take it apart once again, and yeah, I need to resolder it. So there must be an issue somewhere. I don't know. You can't really see it on the board, so it looks pretty nice. But there must be an issue. There must be an issue somewhere on the board, and that is what we need to find. Otherwise, we are not able to solve. Yeah, look at this. So it's moving. So that is not what we want to. And now we have. Yeah, now it's good again, but it needs to be stable. It needs to be stable. Otherwise, yeah. Otherwise. You will not get your transmitting signal under control, so that is an issue, definitely. That is funny. This is another curve of 7 megahertz low pass filtering. So yeah, that is really funny. So, well, we need to find what it is causing it. and yeah, filter board is now on the bench, and yeah, we need to check it. We need to find the reason for that behavior. Maybe we have an issue with relay or whatever. Look at this. So there is somewhere yeah, somewhere here must be an issue. Somewhere, I don't know. We have to find it out, and we need to fix it, otherwise it won't work in the radio. Yeah, low pass filtering. That is low pass filtering. Okay. Well, just a little excursus what we are doing here. So as you have seen, I've tried to find the issue why the low pass filter board is unstable on 7 megahertz. So therefore I'm reproducing here the filter response. So that is what you can see on this screen. So this here is the marker, which is put on 7.1 megahertz. So that means from nearly 0 to 7 megahertz. So there is very low attenuation. So I'm injecting a signal of minus 10 dBm, and what you can see here is the output response. So how can I bring it on the screen? Very simple. So this is a tracking generator as well, and I'm injecting from the tracking generator output a signal directly here into the input of the low pass filter board, and for 7 megahertz, so 40 meter band, this components here in this line are responsible for the low pass filtering. So we have different bands, and therefore we have different low pass filters, which are switched by these little relays at the input and at the output. And finally there is an antenna switch, which is switching the antenna to the RX of the transceiver or to TX. So with the generator here, that is very simple, because I'm injecting a sweep signal. So I'm sweeping over the whole frequency. So that means starting with nearly with nearly 0 and up to 30 up to 20 megahertz, and this is at least the filter response of the tracking generator. So what you can see here is well, we start with a frequency of 20 kilohertz, and our stop frequency is 20 megahertz. So continuously the frequency is going from 20 to 20 kilohertz to 20 megahertz, and then you are able to see on the screen the filter behavior. And well, low pass filtering means only the low frequencies passes through. So with the injected signal of -10, you should have no attenuation of the signal in your wanted frequency range. So if I have a marker here on 7.1, this shows clearly that we want to have full signal within this range, but if the frequencies are getting higher, then the filter should attenuate the signal strengths. So that is what this falling signal is showing here. So if the signal is higher than 7 megahertz, so for instance I can move the marker, and you always can now see where the marker is, so you can see it here. So while I'm moving the marker over the filter, you see where we are. So there is no attenuation until nearly 8 megahertz, and if signal strength frequency is going up, not signal strength. If we have a higher signal as 7 megahertz, then you can see now here's a marker. So marker is now on 11 megahertz, and 11 megahertz already gets attenuated by 20 dB. So injected is -10, and you can see it here. Marker is at -30 dB, so that means signal is already attenuated by 20 dB. So that is what you want, because as we know, the second harmonic is of 7 megahertz, so 40 meter band is around 14 megahertz, and if we are moving here to 14 megahertz, so marker is now on 14, so that is down here, and if you count 1, 2, 3, 4, 5, 6, so that is approximately 60 dB attenuation, and that is what you want. So you want attenuated your harmonics. Well, and that is as well a very nice way to check how your low pass filter is working. And as you see it in here, I have taken out a relay, because I figured out that there must be something wrong with the relay, and this is the relay from or out of the 40 meter band, and I've taken another relay here from so that is from 20 meter band, and moved it into the 40 meter band place, just to check what's going on. And well, now we can be sure that this relay is not working properly, so that needs to get removed. And if I have removed it, then we can be sure that the filter response is like it is shown in here. So there is nearly nil attenuation in the frequency range we want, and full attenuation in the range where we don't want it. And everything else we have seen here as filter response with the old relay before is what we don't want. So yeah, so that is next. I have to order new relays for the 20 meter band. So there is still the second one, so at the input, which is not as it should be. So I'm gonna change both the input and the output relay, and then we can be sure that 40 meter low pass filter will work again as it should work. Yeah, so that is just a little excursus for how you can measure such things. Yes, the new relays are delivered. So here are the new little puppies which have to go into our low pass filter. Okay. Yeah, so they are really still available. Relays are brand new and are absolutely identical to the old and defect ones. So we're gonna change the old one and replace it with the new one, and then we're gonna check what has happened. As you can see, new relays are in for the 40 meter band. Still no relay for 20 meter, but I just wanted to test how it works, and if our fault is now under control. So they are in, they are soldered completely, and board is clean, so very nice. Okay, so then let's check. Tracking generator is already connected. So first let's switch our transmit and receive relay, which has switched now. And now we gonna switch our both relays for the 40 meter low pass filter. and this supply comes from this little power supply. Yeah, switched on, and look at this. So that is really a nice signal. So that is a filter response as we would expect them. Yeah, I can now do anything I like to the PCB. Yeah? I can bend it like hell, you know, and nothing happens to the low pass filter. So that is absolutely clear. So the old relays are dead. So I have measured the resistor of the contacts, and so what I can say so far is that when you supply 12 volt to the leads here, and then measure the resistor, the contact resistor, and I notice that it is 100 ohm or more. So that for it alone is a clear indication that the relays are dead. So with the new relays in place, and with a really beautiful filter response on my spectrum analyzer, that is really great. That is really great. So so you may remember when I am placing my marker to 7.1, so that is 40 meter band. You can see, as I told before, I'm injecting minus 10 dB, and on the other end, so this side is input. So input is here, and this is output, and so there is no attenuation through the 40 meter bandpass. Well, that means at least even if the other relays are still working, but you have to expect that in a while they are going dead as well, and you can't do anything. So I've tried to clean contacts, and I've also tried to bend a bit contacts so that they might get a better contact itself, but it doesn't help. So, you know, after 20 years or what, so contacts may be burned out, and that seems what has happened to the contact. So, so they have only a predefined life, and so that's what it is. So if they are dead, you have to change them. Simple. Okay, so once again, this nice filter response curve, so that is great, that is fun, that is really fun. Okay, so I'm now changing also the relays for 20 meters, so that is what I thought, because 40 meter, 20 meter and 17 meter, So that is what these both low pass filters are responsible for. And yeah, so I gonna change this relays, and then I bring it back into the cabinet, and then we can check how transmission is working. Now, same for the 20 meter band, so relays are in, and as you can see, it is really a very nice filter response. So when I switch filtering off, it's gone, and back, you can see it is really a nice filter response. So the only thing I found is the fact, yeah, so that is 14 megahertz, where you can see the little marker. So that is 20 meter band, and yeah, this radio doesn't have own low pass filter for 17 meter. So for 18 megahertz they're using the same low pass filter. So we only have 7 mega and 14 and 18 mega, and then we have a filter for this down here is for 10 meter and 15 meter and 160 meter and 80 meter, but there is no own filter for the 18 megahertz and the 24 megahertz. So that means the 18 megahertz has to go through this filter as well, and what you can see, if I move my marker to 18 megahertz, so now we are approximately in the 17 meter band, so marker 18150, and 17 meter ends at 18163, or what is it, I don't know. So yeah, so that is the point. We have already 10 dB attenuation, so that is a disadvantage when you don't have a own low pass filter for this band. Yeah, but you can't change it, otherwise you need to create a new filter board. Anyway, but filter response is great. So this is now the proof that the filters, the relays are, yeah, gone after 20 years plus.